In Learn 3.3, we're going on to quadratic functions. And looking at the objectives, they're quite extensive and maybe a tad more challenging than what we've done. So take a moment, take a look at them. Now, there is a proper way to display quadratic functions, and we see it right here, where the function of x is such that it equals ax squared plus bx plus c. Now, this is the right side of the equations would be the quadratic expression standard form, where a, b, and c are real numbers, and a, that would be the coefficient of the x squared, cannot equal 0. And these are known as second-degree polynomial functions because our power of x here is x to the second. Now, the shape of these is a parabola, and if we have a particular equation, and we're looking at this function, which is the simplest form, and we make a little t-chart and put values into it, here's what the parabola looks like. Now you'll notice there is a axis of symmetry, which is the y-axis here. That sort of divides the parabola into two sides, where one side is the reflection of the other. The base of this parabola is also referred to as the vertex and would be a minimum. We sometimes have parabolas that open downward, so the vertex would be on top and would be known as a maximum. And we see there is a point of origin here. The vertex is also the y-intercept and also the x-intercept. So a little review of terminology. What we're seeing in this particular slide, we saw the function of x is x squared. How about if the function of g is, in parentheses, x minus 3, the quantity squared? Well, again, if we made a little t-chart, we'll notice that everything is pretty much the same, but the graph shifts 3 units over to the right to a positive 3, comma 0 as its vertex. And looking at that again, when there is a negative in this position and the quantity is squared, the value of what is going on here is it's going to shift it 3 units to the right. Now, looking at another function, we see h of x. In our parenthesis, it's a plus 7, the quantity squared. If here, this is going to end up as a shifting it 3 units to the right, what will a positive 7 do you think here? Again, you can make a t-chart and notice it's shifting 7 units to the left. So a kind of a hint, when you see it in this form, if it's a plus 7, it's shifting it to the left, in a sense, a negative 7. And if it's a negative 3, the opposite sign, it will shift it to the right. So how about this function? J of x is equal to x squared plus 5. Now, we knew what the x squared by itself did. What happens if it's a plus 5? Well, notice this is sort of in the position of the y-intercept, the b value. And if you said it's going to shift it up on the x-axis 5 units, that is correct. And in this case, if it's going to be from a positive 5, we're changing it to a negative 2, it will shift the graph vertically down to the y-intercept of negative 2. Okay, we'd like you to compare now these two graphs. Notice our vertex is 0. And what happens in stretching or shrinking a parabola? Now, you'll notice that in red, the basic parabola is our x squared. But if we put a 6 x squared, what will happen to it? You see it shrinks to the blue parabola. That is, having a coefficient greater than 1 for our x squared causes the parabola to move closer to the y-axis. And we're looking for some general patterns here. Well, how about if it's a negative 1/2? What would happen there? Well, if our coefficient of x squared is negative, the parabola is going to open up downward. And let's take a look at that in this next one. So this is where our value of a is 1 x squared. This is our red parabola. If we make it a negative 1/2, it's going to open up downwards. And notice that instead of shrinking toward the y-axis, it expands. So we see it illustrated here. Again, all some background material of what goes on in a parabola depending on the function we are graphing. Now here we'll take a look at what is called the vertex form of a quadratic equation. Now you know the standard form of the quadratic equation, y equals ax squared plus bx plus c. Now there is also taking that same equation and putting it into this form. And it is something you'll have to memorize. The function of x is such that we have a, and then in parentheses, x minus h, the quantity squared, plus k. And they give you some restrictions here. Now, the absolute value of a, we want it to be greater than 0 and less than 1, pretty generally. So, looking at what we've had so far, as we consider other forms of this, here's your basic parabola function. Here we're shifting it a little bit. Now remember, if h, this value, negative h, we had a positive value that we shifted to the right or left. And if it were negative, again, depending on the sign, it's a little tricky because there's a negative in this formula. Now, when we get to this third one, this is providing a k value. Now, when we look at the letters h and k, interestingly, this will make up what is called the vertex. Remember, if it opens upward, the vertex was a minimum at the bottom. If it opens downward, then the vertex is a maximum at the top. And then finally, we put that coefficient A out there. And again, if our A value is negative, then it's going to open downward. If A value is positive, it will open upward. So again, hopefully you're taking some notes, and we will be reviewing this, of course, as we go on. Now, throughout the Learn, there are videos on various topics available by the authors of the textbook. And what I'm doing is giving you a general video background for all of this, but you can always go to the videos when you are in Learn. I tend to hide them. And let's look at example 1. They want us to sketch the graph of this function, locate the vertex and the x-intercepts. Now we're finally getting to example 1, and then we'll have some more examples, of course, in our practice. So there is the function that I've copied, hopefully correctly, yep. And this would be in its standard form of the quadratic function. Now we're asked here to find the vertex. Now to do so, they're suggesting we convert from standard form into the vertex form that we just went over. And then once it's in the vertex form, we can just pick out the vertex by finding our h value and our k value, which is the formal way of presenting the vertex. Now for this, I'm going to use the whiteboard, keeping in mind that the authors have produced a video on this too. Actually, I watched it. Okay, now to put it into this form, there is a protocol, and we're going to use what is called completing the square to do so. And here's how we start off. We want to separate the first part of this and take out a negative, and then this will become x squared. It's a positive x squared now. Change this sign. This now becomes a positive 2x. And we don't know what our c value is. Right now it's a 3. But we want to make this a perfect square. It's not a perfect square in this form. And we're going to take this 3 and just put it out over here, temporarily here. Okay. Now, to make this into a perfect square, we have to remember the protocol of squaring a binomial from an earlier lesson, where this is going to be x. Our b term was taking this, multiplying it by this, and then doubling it to get our b value here. But right now it's a 2. If it was doubled, what was it originally? But it was a 1. Okay. So now if I expand this, and I'm going to change colors here. If I expand this, I get this, but now squaring this, I get here a plus 1. Now up to this point, before I added the plus 1, this was sort of balanced. But since I added a 1 here, to keep this true, I have to add a 1 there. So what do I have now? Well, I have a negative x plus 1. the quantity squared, plus 4. And I don't know if you can see it or not, but now this is in the form, the vertex form of the quadratic equation. So now let's pick out our h value and our k value. Well, our h value, remember, it's going to be the opposite sign of what's there. So that'll be a -1. And our k value is just whatever that is, 4. And this is our vertex. Now let's go to the screen and see what they're showing us here. Yep, right there. Our vertex is -1, 4. It's in this form. Now, they're going to ask us to find the x-intercepts. This is often said to find the zeros. And that is when our y value here is 0, whatever is here is going to be our x-intercepts. Well, if we were to take that equation that we have, and let me set it up on the whiteboard for you. It looked like that initially. Well, it's always easier to solve this if our a term here, which is a -1 right now, is a +1. So I'm going to multiply each term by a -1, and that reverses all the signs. So I now have x squared plus 2x minus 3 equals, and again, 0 times -1 is still 0. So I want to see if this will actually factor. Again, skill we had earlier, and it does. Now, what would your signs be? We need a positive in the middle. Well, this would be a positive, and this would be a negative. And the protocol is equal each of the factors to 0, and we get here x equals a +1, and here x equals a -3. So remember, these are ordered pairs. So we're going to have a -3, and here a 1, 0. So again, we have our vertex, we have two ordered pairs, and if we're asked to graph this, which I think we will be, we'll see how it works in there. And of course, this is what they're doing. And they're showing how it's listed below. Now, sometimes they'll ask you to find other values, and but here they're actually showing us the graph. And notice there's our vertex, which is a maximum, and the value of this was -1, 4. And then there's one of our zeros, -3, 0. And there's the other 0, 1, 0 that we figured out, and they're illustrating it. Again, take some notes as you watch this. This is your viewing of the protocol of what to do. And the real cool part of this is if you have a graphing calculator, you can actually put that in there and it shows you what the graphs look like. And you can use the trace function to see various points. Now I should mention, if you go to the upper right corner, there should be a circle up there with the letter I in it. I've put in some basic background work on completing the square, which is a technique that was featured here, but we didn't go over in great detail. All right, now what are they saying here? Well, they're saying this is the equation in standard form, quadratic equation. We did use this to get the quadratic formula, which can be used to find the zeros, but it also could be used to convert from standard form into the vertex form, which is what we see here. And I'll raise it so you can actually copy it into your notes. You don't need to show the derivation of this, but there it is. So that your x value in the vertex is negative b over 2a, and the y value is derived by this formula, 2ac minus b squared, divided by 4a. Now, you'll need to have that in your notes, and you'll be asked to use this in future examples. So have that written out somewhere. As we go on to example 2, I've written these two equations, and we're asked to find the vertex of each. And using the quadratic vertex formula here, let's go to the whiteboard. Now we need to identify the A, B, and C. Our A here is 1, our B is negative 4, and our C is 8. Here it's going to be 3, B is 5, and C is negative 1. Now we know to find the x coordinate, this is pretty straightforward. It's negative b over 2a. So negative b would make this a positive 4 over 2a. A is 1, so this would be over 2. So our x-coordinate is going to be 2. Now another way of doing this, other than using this, is just to put the 2 into this formula. And that'll give you what your y value is on the outside here. So if I do that, this is going to be 2 squared minus 4 times 2 plus 8. So this is going to be a 4 minus 8 plus 8. You see these two will cancel out, and this just becomes 4. Now if I put all of this into this, it would come out. Now, why would we want to use this seemingly tedious method? Well, because here it's going to end up being fractions, and that gets to be tedious, and that's what they're illustrating. So let's do that. So we're going to get 4 times a, which is 3, times c, which is a negative 1, minus, now b is a 5, that we're going to square all over 4a. Well, 4 times a is going to be 12. So this is going to be a negative 12 here. And this is going to be a negative 25. And this then becomes, let's see, a negative 37 over 12. So if you had to substitute we didn't get our other value here. This one will be easy. This is going to be a negative b is a negative 5 over 3 times 2 would be 6. So our ordered pair here is a negative 5, 6 and a negative 37, 12. So you can see why this formula then would be much useful if you had to try to square this and then work with fractions in that way. Okay, let's look at the regular and see how close we are to the answers. Hopefully we're on the money here, so to speak. They're showing us all of this, and there it is, negative 6, 5, 6, and that. And then the other one that we had was a 2 and a 4. Yes, we're good. I wanted you to see this worked out, but again, all of this is in the Learn. In example 3, we're asked to find the quadratic function given the graph. So it's sort of undoing what we've done. And again, there is a Hawks video that they have produced. I'll give it my shot here. So what is the protocol for this? Well, the first thing is to find your zeros here. So this would have been, we do it in a formula form here, we'd have A something times something. And what value would have been there? Now this is a negative 1, so that would have been a positive 1. And this one would have been a negative 2. So using the zeros, that is our x-intercepts, we can do that. Now, what were our x values here? Well, we said they were 0, so we can put a 0 there and a 0 there. So in a sense, this just becomes then plus 1 and a negative 2. Now, what we don't know at this stage is our a value, but we also have a value for our y out here that I can erase. This is going to be a y. And what is our y value right there? When x is 0, it's 4. Okay, so we now have 4 equals 1 times negative 2 is negative 2a. So we're going to divide both sides by a negative 2. And we get a is negative 2. So let's look at what the book has too here. That'll save us a little time. So there we've gotten our value for a is negative 2. They're just now going to put, again, negative 2, and then keeping in mind this is an x and x, we're going to FOIL that, multiply through by a negative 2, and there we have our solution to part A of this using this particular technique. So what is it again? Well, find the zeros, put that into an equation, find your A value, multiply through, and here it is summarized. Now to find the vertex of it, we would need here to use the vertex formula again, which is illustrated here. So pause the tape at this time and then copy this in your notes, checking the math as you do it. I see this video is running rather long. Going on now to another objective, it's quadratic regression, and it's following the similar protocol of what we did in linear regression. Let's take a look at an example. This is number 4. And you might say, what would you do here to get what would be a quadratic equation for this? Well, you're going to need your data points here. And trying to speed this up just a little. Hopefully you're going to be able to use technology for this. These are the data points. And then once you put that into the system, showing you that technology, it gives you this function. Now, from this function, you ought to be able to find the vertex using that vertex formula, and that would be this example. Again, we're not going to go into it in great detail, but notice that this point is not the vertex. The vertex is somewhere there, and that's what they'll be asking you to find. Looking at example 5, again, 3 points. Let's go back so you can check them out. Here, this is going to be -2, 0. This will be 0, -4. And this one is going to be 6, 8, as we see there. Put that into your software or calculator, and this is what you get. Now again, it looks like this, but the 4 is not the vertex, the -4. It's over here somewhere, and you'd have to use that special formula to figure it out. Here they're showing it's a 1 and a -9/2. You're going to need to know how to do this to do the practice and then later the certify. Continuing on with problems related to the quadratic formula, we're going to take a look at what is called maximization and minimization problems, where if we're looking for the maximum, that would be the vertex, where our a value in the quadratic equation is negative. And for minimum, it's where our a value is positive and looks like this. We reviewed that earlier. Here's example 6, and we'll go over this one in some detail. There is a video for it. Now, a farmer has 100 feet of fencing, and this is a picture of his barn here. And what he'd like to use is this fencing to make a area for gardening of some type, where the side of the barn is one wall or one side, and he's going to do the other sides. So what's going on here? Well, we don't know what the width of this maximum shape would be, so we're going to call it X. Now we have 100 feet of fencing, so this is a 1x and a 1x. If we subtract that 2x from 100, we'll have this length side. And we know the formula is area equals length times width. And there is a width here, and this is our length. Well, we could use an x here. So if we put this in standard form, put a -2x there, squared, and then plus 100x, we have the start of a quadratic expression, which there is no c value. But we want to find the vertex. We want to find the maximum. this parabola is going to open upward here. And we can use that negative 2, or I should say negative b over 2a. And our b is 100, so a negative 100. And our a is a negative 2, so that would be negative 4. Simplified, our x value here for the vertex is going to be 25. So what would be the dimensions then of that maximum area? Well, x is 25. 2 times 25 is 50. 50 from 100 is 50. So the answer to this example would be, the dimensions would be 25 feet times 50 feet. All right, let's scroll down and see how close we are on this one. And there it is, 25 by 50. So in example 7, pause to read it. Okay, well, these are some of the data that she shows, which can be put into ordered pairs, which then can be put into an equation, of which we get this. So to find the maximum from this equation, let's pick it up here. Our b value is 18, so that'd be a negative 18 over 2a, which would be a negative 2. So it would be $9 would be our maximum for charging for this particular item. So $9 looks good. Now there is a second question. What would be her revenue then? That is money sold. Well, we need to find the y value. So putting the data into this formula, we get $81 as the corresponding price. Okay. Now, if you made the graph, you can almost go there. There is 9, and then it's just a little higher than 80, 81. Also, if you put $9 into this formula here, that would be the other shortcut way. You wouldn't need this somewhat cumbersome formula here. They do give a little more on the technology using graphing calculators. This is, of course, for maybe a future lesson here. So let's wind this up.